LLaDA 2 is here. I covered the first version of this LLaDA model around 7 months ago, and it was a quite interesting take. In this video, we are going to install this new version of LLaDA and we will check out what exactly is the use case here. This model is an instruction-tuned diffusion language model that uses a mixture of expert architecture. It is part of the LLaDA series and is optimized for practical downstream tasks for chat and generation rather than just raw pre-training. And that is quite interesting. The mini preview tag indicates that it is a compact variant, and as far as I can see, it has 16 billion total parameters which are non-embedding, but only about 1.4 billion parameters are activated at inference thanks to its MOI design. Because of this selective activation, this model aims to achieve a favorable trade-off between computational cost and performance. This is Fahad Mirza and I welcome you to the channel. Please like the video and subscribe and consider becoming a member as that helps a lot. And if you're interested in other LLaDA models, just check out on my channel. I'm going to use this Ubuntu system to get it installed, and I have one GPU card NVIDIA RTX A6000 with 48 GB of VRAM. If you're looking to rent a GPU on very good price, you can find the link to Massed Compute in video's description with a discount coupon code of 50% for range of GPUs. Let's install all the prerequisites which include torch and transformers. And meanwhile, let me introduce you to the sponsors of the video, who are iGent, which is the world's first multi-agent workforce desktop application, empowering you to build, manage, and deploy a custom AI workforce that can turn your most complex workflows into automated tasks. Coming back to what is happening in this model, so LLaDA mini preview in terms of use cases is intended for text generation, instruction following, chat agents, complex reasoning, code generation, and other tasks where you want a balance of performance. It also supports tool use and tool calling, which is quite a jump from its previous version. And the good thing is that as it's a mixture of expert architecture with 20 layers, 16 attention heads, and context length is 4K, which is a bit smaller. But of course, it uses a rope and vocabulary sizes around 158K tokens. Its diffusion style training paradigm, as opposed to purely autoregressive, is what makes it different. And that is why we call it diffusion language model or DLLM. And I have talked a lot about this architecture in my previous video, which still holds. So if you're interested in what exactly is meant by diffusing the word as it generates, just check out this previous video. Okay, let's go back and see what is happening. It is all the prerequisites are done. Now what I'm going to do, I'm going to download the model. For that, just log into Hugging Face with HFauth login and give your read token. I am already logged in and I have just created a local directory, and in order to get this model downloaded, all you need to do is to just use Hugging Face CLI command. And let me quickly paste that command. I need to copy paste it. I forgot to copy it. So just give me a sec while I copy and then paste it here. So I'm just getting it from Hugging Face and putting it in local directory. Let's wait for it to get downloaded. And while it downloads the model, let me give you a very quick overview around the inner happenings of this model. So they also have this very cool paper which I covered last time, and you can read through it. It is still very much valid. Now what happens in the diffusion LLM is that instead of writing text strictly one token at a time from left to right, a diffusion LLM learns to reconstruct missing words. During training, it takes a sentence, randomly masks some fraction of the tokens, like hiding words with blanks, and trains a transformer to fill in all the blanks at once. Generation then runs this in several rounds. Start from a fully masked output, repeatedly predict the missing tokens, keep the confident ones, remask the uncertain ones, and refines until the whole response is complete. This setup forms a forward masking process and a reverse unmasking process. And the training objective is a principled likelihood bound, so it remains a true generative model. Now, the way it differs from the traditional and normal models is that the autoregressive models guess the next token only using the causal mask, which means from left to right, and generate strictly sequentially. Whereas this one, diffusion LLM use a bidirectional transformer, there is no mask, and it can update many tokens in parallel each step. This produces different trade-offs. First, bidirectional reasoning can help on reversal tasks where you can predict the preceding line as well as the next. So right to left to right and right to left. Sampling is iterative, so you choose the number of refinement steps to trade speed for quality. There is no KV cache style speed up from AR decoding, by the way. So runtime characteristics differ a lot. And there are a lot of other things which are happening in this, but I'm not going to go into way deeper. As I said, just check out this video and you should be able to get the hang of it. Meanwhile, the model is downloaded. Let me now show you the code, which you can also copy from their model card, which I will drop the link in videos description. All we are doing, we are using the same transformer based architecture where we can download the model. We already have it, and I have just given it the path, and from there I'm asking it, for example, say the word tomato 3 times, and then model is generating the output after encoding the data, and then we are printing it out. That is all there is to it. But the real cool thing is around diffusion process, which I have just described. But anyway, let me take you back and run this. And there you go, the model has given us the response after loading it, and the speed was quite interesting too. Okay, let's try out another one. I'm just going to ask it bit of a grounded question, so I'm asking it refine and answer iteratively like a diffusion model. Start by outputting an all mask reply of exactly 32 tokens written as mask, and then perform 4 refinement rounds. At each round, replace only the tokens you are most confident about and keep the rest as mask. And after round 4, output the final fully unmasked answer on a new line, and the topic is explain in 2 sentences how transformer use attention. Okay, now let me run this, and while it runs, let's check the VRAM consumption. So it is consuming, as you can see, as it runs. I will let it run so that we could see it is jumping up, going up and up. Okay, keep going, keep going. So still at 32, I guess around 32 gig of VRAM is the max. Nope, it is still jumping up. It is doing the rounds, I believe, and that is why it is jumping up, as you can. And because if you look here, it is still, after loading the model, it is still doing the inference rounds. And now it is staying at 30, just under 34 at the moment. So it is, I'm just watching it how, I don't think so it is going to go beyond my 48 GB of VRAM. So I think that should be 8 around 35, 36. I don't think so it is going to go up there. Okay, let's wait for it to come back and then we will check out and I will tell you how much max VRAM it consumed. And there you go, the model has come back with the answer and the VRAM just hovered around 40 gig, and it has run the 4 rounds, and this is the answer where it says that transformer use attention mechanism to dynamically weigh the importance of different parts of the input sequence, allowing each word to focus on relevant context within the entire sequence. The answer is perfectly fine. So look, very interesting model. Let me know what do you think. Please like the video and subscribe and consider becoming a member, as that helps a lot. Thank you for all the support.